Hello everyone, welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be continuing from our most recent upload on the channel, where we went through the 2024 January mathematics exam for the Caribbean Examination Council, that is Caribbean Secondary Certificate Examination for Mathematics. Of course, a link will be pinned in the comment section below that will take you to that particular part 1 upload, where we went thoroughly through the solutions for question 1, 2 and question 3. So of course, in this particular video here, I'm going to be going through questions 4, 5 and 6, and then of course we're going to be continuing like this, trying to make this video at least a little less than an hour long, and I'm going to be walking you through all the steps that you need to take. I want to also develop the analytical ability for you to think your way through the questions. All right, so far it seems to be a really decent paper. It's not very challenging so far, but it did of course required a little bit of thinking. You had to know you had to have knowledge on the topics that were presented in questions 1 through 3. All right, so you can definitely check that out at a time convenient to you. But of course, if this is the first time here on the channel, do not forget to hit the subscribe button below for weekly and daily tutorial uploads. Of course, do not forget to leave your opinions, thoughts, suggestions down into the comment section below. Ensure that upon watching this video, you guys are in fact having your pens, pencils, calculators, and you're working with me, so you can attempt the questions and then match your solutions with mine. All right, and of course, before you leave the video, if you have found any sort of value, be sure to hit the like button. It really does help the channel to grow. All right, so without further ado, let's dive on right in and start off here with question 4. All right guys, so here it says for question 4, consider the following functions. That is f of x equals 2 take away 5x, and h of x, say here, equals 5 to the power of x, and we're asked to calculate, say here, f of 4. So for this then, f of 4 is simply going to be that we're going to be replacing x in the function with 4. So replace the x that is in the f function with 4. So this is going to be 2 take away 5 multiplied by, say here, 4. So nicely then to be 2 take away 20, and that is equal to, say here, minus 18. All right, pretty easy so far. Not much challenge here, just a mark for that one. We're then asked to work out h of 0, so we're going to replace the x here that is in the function, the h function here, with 0. So then this pretty much works out that this is 5. It says 5 to the x, it must be 5 to the 0, and of course, according to the laws of indices, that says a to the power of 0, we know that any quantity that is raised to the power of 0 is in fact equal to 1. So therefore 5 to the 0 is 1. All right, and so therefore then moving on to, say here, f of h of minus 2. So there's a couple of ways to actually do this. I'm just going to be doing it the easiest way here. What we're going to be doing then is that we're going to be taking the negative 2 here and we're going to put it into the h function, and then the answer that we got for that substitution, we're then going to put that answer back into the f function here. So the very first thing that I want to do here is to split this apart into f open bracket h minus 2. And so by splitting that apart, then we can therefore then work out h of minus 2. So that's going to be then equal to, say here, 5 raised to the minus 2. So 5 raised to the minus 2, according to laws of indices, that says a raised to the minus 1 is equal to 1 divided by a, that's law of indices number 4 or number 3, I think it was. So therefore this 5 to the negative 2 will become 1 over 5 squared, which works out to be 1 divided by 25. So that is h of minus 2. So therefore then we're going to then find f of 1 over 25. So we're going to plug 1 over 25 into the f function, which we then know here is 2 minus 5 times x. So that's going to be, say here, 2 multiplied, pardon me, not 2 multiplied, my apologies guys, it is 2 minus 5 times x, which in this case is 1 over 5. Alright guys, so I did made a little error here. I had some issues with my audio and as well with my visual, so I accidentally inserted there, as you can see, 1 over 5 when it should have been 1 over 25. So when I cancelled the 5 and the 5, I should have cancelled 5 into 25, and that would have given me, say here, 2 minus 1/5. And then I would have to use, say, find the LCM then, which should have been 10 minus 5, which is 5 over 5. Alright, so you can just make the necessary corrections on that one, and let's just continue the video. That this is referred to as the inverse function. Alright, and there's a 3-step process to finding the inverse of a function. The very first thing we do is that we let the letter y be equated to the function of f, which in this case is 2 take away 5x. Right, and then we're going to interchange x with y. So we're going to have x then is equal to 2 take away 5 times 5y. Replace x with y. And then our only task here is to make y the subject. So let me just write some notes here for you. We're going to let y equal function. I do not have a tutorial out on this as yet, but hopefully in the future I will. And then of course in this step here we're going to isolate. So that's isolate, say here, y, make y the subject of the formula. So we're going to therefore then go ahead and bring this negative 5y to the, say here, left. So that's positive 5y. Love to keep my subject positive. Of course, I'm going to leave the 2 on the right and then transpose, say here, the x to the right side. So that's negative x. And then easily then we can just split the product here by dividing both sides by 5. So that's 5y divided by 5. That's equal to 2 minus x divided by 5. Cancel, cancel. Y is equal to 2 minus x all divided by 5. So therefore, once I've attained, say here, the value, the y as a subject, my conclusion then is that f raised to the minus 1 is equal to, say here, 2 minus x divided by, say here, 5. Alright, so that is how you'd approach that particular question. Then let's move on then down to this section here, this applied question, that given that f of x equals a plus bx, determine the values of a and b. And this can be quite a tricky little question for a lot of students, because this is requiring you, the prerequisite skills for doing a question like this is pretty much having an understanding of making an equation then. So we need to find, say here, what is the expression that represents f of x. And once we have done that, we're going to equate it to, say here, a plus bx, and then we're going to solve the equation for a and b. All right, so f of x, then let's work that out. F of x means then I'm going to plug the f function into the f function and see what comes out for that. So therefore we're looking at, say here, f of 2 minus 5x. So that means anywhere I see an x in the f function, I'm going to replace that x with 2 minus 5x. So therefore then what we're looking at then is, in fact, 2 take away 5 open bracket 2 minus 5x. So replacing the x that is in the f function. So we are pretty much then going ahead then to, let's go all the way up here. We are going to just replace this x right here with the actual expression representing the function. Then, yes, so once we have done that, then we end up having this expression, which we're now going to be equating then to a plus bx. All right, so let us distribute here. We have 2. All right, then we're going to have negative 5 times 2, that's negative 10, and negative multiplied by negative gives us a positive. 5 times 5x is 25x, and then that's going to be equal to, say here, a plus bx. All right, so now we can simplify this equation then, and we end up with 2 take away 10, that is negative 8, plus, say here, 25x. All right, and that's going to be equal to a plus bx. So what we're going to be doing then is that we're going to be comparing, let's write it down here, we're going to be comparing coefficients and constants. So we're going to be comparing, let's not say compare coefficients, so we're going to compare values on the left. So we're going to compare, so comparing the left hand side with the right hand side. All right, that's what we're going to be comparing. So if you pay close attention to this and you look at the comparison, you'll realize that minus 8 is in front of the plus sign, so minus 8 would be corresponding with a. Then the 25 here is right in front of the x, and the b is right in front of the x. So by comparing the left hand side with the right hand side, it seems as if a then is equal to minus 8 and b here is equal to 25. All right, so definitely an interesting question here, very different from what we are expecting. I don't really teach a lot of these types of questions in my class. Most times CSEC sends the question that requires the students to really think through the problem then. All right, so that's a nice question there. All right, so hopefully you guys will have an understanding of how to do that. So in the future, when you get a question like this, you can in fact apply and get your full marks. Also, before leaving this question, as I go through, it is key to note that this f of x can also be written as f squared x as well. So if in the event that you see something of this nature, it is the same approach here. F of x is the same thing as f squared x. All right, beautiful. Let's move on then to, say here, the question down at the bottom here, question 5. All right, now statistics is what we're looking at then in this particular section of the video here. It says that the mass m in kilograms of 120 newborns at a hospital is recorded in the table below. So the mass here, you can see that these are the upper boundaries and lower boundaries and upper boundaries, and they are stuck between a domain. So the mass here in this column here is that the mass is greater than 2.6 kilograms, but at the same time less than or equal to 3.5 kilograms. This one here is greater than 3.5 kilograms but less than or equal to 4.4. This one here is greater than 4.4 but at the same time less than or equal to 5.3, so on and so forth. And on over this side here we have the frequency. This represents how frequently mass, or how frequently a mass between this domain here has occurred. So we had 7 masses that were occurring between 2.6 and 3.5, 3.5 and 4.4. We had 18, then we had 30 occurring between 4.4 and 5.3, so on and so forth. So now we are expected here to state the modal class. Of course, the mode is the frequency that occurs the most, and you can see here clearly by the numerical values here that 30 is in fact the highest one that has occurred here. And so we're not looking for the mode, we're looking for the modal class. So this here, this domain here is our class. So our answer for this question then is that the modal class is 4.4 is less than m, but at the same time greater than, less than or equal to, say here, 5.3. Right, that's the modal class. Go on down here where we see complete the table and calculate an estimate of the mean mass of the 120 newborns. So we need the mean mass here. That's what we need, the mean. So we have 3 marks then. So we have to first complete the table, then we're going to be calculating the mean. Now before we actually complete the table, let us recall what is the mean formula. So the mean formula here is that x bar, that's the mean symbol, that's the average symbol in statistics, that is equal to the summation of f times x divided then by the summation of, say here, f. All right, so once we get the summation of the function of x, or sorry, once we get the summation of the frequency times x, and we get the summation of the frequency, then we already know that that's going to be our mean. But before we do that, let us go ahead then and fill out the table here. We need to fill out this particular column here. And so if you were to go ahead then, guys, and you can test it, the midpoint then, if we know anything about midpoint, we will learn that midpoint is actually equal, so that's the midpoint of a class. So midpoint is equal to, say here, the upper bound plus the lower boundary divided by, say here, 2. All right, and so we can test and confirm this if we take the first row here and take 2.6 and we add that then to 3.5, and then of course if you divide that by 2, you recognize that you can actually get 3.05. So we know that to fill this column out here, we're going to simply take 5.3 plus 6.2 and divide then that by 2. So you understand that here you get 5.75. Okay, that's for that part. And then for the bottom here, we're going to take 7.1, we're going to add that to 8.0, and then if you divide that by 2, we get 7 point, say here, 5.5. So that's 7.55. all right, and then of course it says here that this is the frequency, which is here. All the values in this column here is going to multiply the midpoint here, and that's going to be all the values over here to produce the answers over here. So we can confirm this then. If you were to take 7 then, that is in this, and multiply it by 3.05. It's always good to confirm, guys. 3.05, that's going to be 21.35. So we confirm that it is the midpoint times the frequency that gives us the answers over here. So to fill this column out here, we're going to have 5.75 multiplied then by 29, and that gives us 166.75. all right, and then of course we have 7.55 times 8, 7.55 times 8, that gives us 60.4. all right, and then so forth. Of course, we're going to then go ahead and sum the fx column then. So let's just erase this right here. We're going to sum the fx column. Guys, let me just get some space. all right, so we're going to sum the fx column. So we're going to go on our calculators then, and we're going to type in, say here, 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4. we end up with a total summation here of, just a second here, guys. Okay, here we go. So we end up with a total summation here for this column then what we're looking at here is in fact see here 651.3. this actually goes here 600.3, and then of course we're going to divide that by the summation of the f column. We already know what that sum is. It's 120, so we know that this part here is in fact 120. You can confirm that by adding up those numbers, but then we're going to divide this then by 120. So when we do that, then we get a mean mass of 542 rounded off 5.43 kilograms. All right, that is the mass of the distributions. All right, so this is one of the easier questions that I've seen in a few years for statistics. I've seen, as you will see in my other uploads where I work around question past paper 2022, 2023, you will find that sometimes statistics can be a little bit tricky. So just this one was definitely an easier version here. Now, one newborn is chosen at random from the hospital. We are to find the probability that the newborn has a mass greater than 5.3. All right, so it's important here that you remember that probability, so that's probability, all right, is equal to the number of favorable outcomes, divided by then the number of possible outcomes. So that's number of possible outcomes. All right, and so therefore then the number of favorable outcomes would have been, of course, the newborns that has a mass greater than 5.3. So if we go back on our table here and we look at the mass of 5.3 right here, anything greater than 5.3, this is m is greater than 5.3. we're looking at all the values from here coming down like that. So it says greater than 5.3. So we're looking at adding 28 here, 29, pardon me, plus 28 plus say here 8, and so that will give us the number of favorable outcomes. So that's 65, and that's going to be 65 then. So probability is equal to 65 divided by the total, which is 120. You can leave it as a fraction or you can reduce it. We can say 5 into 65 goes, say here, 13, and 5 into 120 goes 24, right? Or you can turn it into a decimal, that is 13 divided by 24, and then we have a probability here of 0.5. all right, or just to put it in terms of percent, 54% chance that you pick a newborn that has a mass of 5.3 or greater. So whichever one you want to leave it as 13 over 24 or 0.54, that's entirely up to you. All right, and then so here for part B, now we are to complete the cumulative frequency table to show below. So for cumulative frequency, then we know that we're going to be adding our current cumulative frequency to the previous frequency. So for the first column, then you realize that this is 7, which actually matches the very first number that is in our table here. Now if you notice that if you were to add, say, 7, right, if you were to add 7, this 7 here, you can see it was projected over here. So let's just copy here. This is called our CF. Notice that they've repeated the 7 over here. Now if you add this 7 here to 18, you'll recognize here then that just a second here, is this undo? Okay, give me a sec, guys. Alright, so if you were to add this current cumulative frequency of 7 to the next frequency, which is 18, you'll recognize then that the answer is in fact, as you see it here on the table, 25. And then of course, if you were to add, say here, 25, say here, if you were to add, say, 25 that we have over here, just a sec. So if we were to add the 25 here to the 30, you'll recognize that you get 55. So our task then is just to add the current number that we have, which is 55, to the next one here. So we're going to be adding 55 to 29. So 55 plus 29, that's going to give us 84. So we go down to our table here and we write 84 here. And then of course we're going to go here and then we're going to have our 4. Going to add that then to 28, so that's 84 plus 28, that's going to give us 112, so that's going to be 112, and then of course 112 plus the 8, that's going to give us 120, that's 112 plus this 8 right here, so this is 112 here, and we're going to add that to 8, we get 120, which of course always equates to the value of the number of newborns. All right, so that's nice, really nice statistics question there, much easier than the ones that I've seen or I've glimpsed before. I believe in 2023 statistics was a very challenging question. So it seems as if every year CSEC seems to have a particular topic that they really put a lot of emphasis on. Statistics was not the question of choice because this is way easier than prior questions. All right, and so let's then move to get graphical now. It says on the grid below, draw a cumulative frequency curve to show the information in the table in part B I on page 16. So we need to draw a cumulative frequency curve here. So the cumulative frequency is going to be mapped against the midpoint here. All right, so we know if you go back to our table here, we know that we're going to be mapping, see here, the values over here, y-axis values, right, 20, and we're going to be mapping that against the midpoint, which is say here on here. All right, let us double check, because sometimes what they'll do is that they'll map the cumulative frequency to the upper boundary, so it kind of depends. Let's check our graph to see if they had given us like a starter. They normally tend to give us a starter, and of course they did. So you can see here, if we zoom up right here, you'll realize that they have given us the x coordinate here and the y coordinate. So if you look here, you'll realize that this is 0, right? 0. So this is in the corner 0 0. All right, and then we have 3.5, and let's read the scale here. This is saying that 1 centimeter represents 10. So it seems as if each of these represents 2. All right, so that's 2, 4, 6, 8, 10. You must be able to read the scale before you start plotting, guys. So for this position here, it seems as if we went across 3.5. So let's just write that down, 3.5. And we went up, say here, 2, 4, 4.5. So that's 3.5, 4.5. So that's how the points are being plotted. So let's go on our table and make a comparison, 3.5 to 4.5. So it's 3.5 to 4.5. All right, 3.5 to 4.5. Where is that 4.5 coming from? 3.5 to 4.5. I'm not seeing it here, guys. Just a sec, let me double check something. Alright, guys, so we're going to be going down, say here to this particular table then. I had to review the paper because I think that a point on the graph was plotted incorrectly. I think this is in fact 84 and this is 112, and this is in fact, say here, 120. So this particular question down here then asks us to, it says here, on the grid below, draw the cumulative frequency curve to show the information in the table in part BI on page 16. So part BI, let's scroll up here to look at part BI. So this is part BI on page 16. So we're going to be plotting, say here, the 3.5 against the 7, 4.4 against the 25, 5.3 against the 55. Now, while I was looking at the graph, right, let us first determine what's going to be key. And here you're realizing that we are at, say here, 2.5 here, and between here there are 10 tiny increments, and from 2.5 to 3.5, that's 10. So I guess therefore then that this is, each of these represents say here 2, so that's 2.5, so that's 2.7, that's 2.9, that's going to be 3.1, then 3.3, then 3.5. So 2 increments, basically each of the increments represents 0.1 y-axis then. So let's just noted that right here, and upon we have 5 increments between a unit of 10 here, so each of these represent 2. Now what was a little confusing to me was this particular point here. It seemed as if maybe it was plotted incorrectly. I'm not 100% sure. You don't usually find errors on CSEC paper, but here we know that the first point to be plotted according to the table is that we're going to plot, say here, 3.5 against 7. So 3.5, clearly we are in the line of 3.5, but my concern here is that we are not positioned at 7, because each of these represents 2, so that's 2, 4, 6, and we're in between 4 and 6, so that's 5. So I'm thinking that maybe it should have actually been right here. That would have been more likely 7. Alright, and then that would be 8, this would be 9, that would be 10. So I think it should have been right here instead. Slight error there on the paper. That should have been the correct answer. Alright, and then if you notice here that this is in fact 2 strokes before this is going to be 4.3, so that's 4.4, that's 4.5. So 4.4 goes all the way up to 25, so you can see that's 22, 24, 26, so right in between here is 25. So this one is plotted correctly. All right, so then we're just gonna have to use that information then and finish. So we're gonna plot, say here, let's scroll up, we're gonna plot 5.3 against 55 and 6.2 against 84. So 5.3 against 55. Let's go down here, find our 5.3. It will be just before here, so 5.3 to 55. Is it 55 or is it 85? Hold on just a second, guys. So it's 5.3 to 55, 6.2 to 84. So 5.3 to 55. 5.3 is just right. 5.3 to 55, we're going to scroll up to 55 here. So 5.3 to 55. I think I've got to zoom out here, guys. So 5.3, that's right here, all the way up here to 55. So 52. Okay, let's zoom in here. Okay, we're gonna zoom in here, guys. So that's 5.3, that's in this line here, and this is 52, 54, so we're going to be just about 52, 54, that's going to be right about here. That's that position. All right, it's a little tricky when I'm using the digital tools here, guys, so gotta bear with me. And then we know that we're gonna have 6.2 to 84, so that's 6.2. so let's go down here, 6.2, so we have 5.5, 5.6, So 5.5, 5.7, 5.9, 6.1. We know that this is 6.3, so 6.2 is right here. That's 6.2. And we're going to go all the way up to 84. So we know that we are about 3 lines, 1, 2, 3 inside 6.5. So that's going to scroll up. Follow me, guys. Help me along. Inside, and we're going to go all the way to 84. 84. So we're 3 lines in 84. This is the line 90. This is the line 80. So we're here. So we're 3 lines in 84. So that's 82, 84. We're about right here to be precise. All right. That's about it. That's where we're at. That's 84. Can be a little tricky, guys, if we don't know what we're doing. If you guys are on graph paper, it's a lot easier for you to find, but I have to be scrolling up and down, so it's a little challenge on my computer screen here. And we're going to be then looking at the next point here. So we're looking at, say here, 7.1 to 112, 7.1. So we're all the way out here, 7.1. So we have 6.5 here, 6.7, 6.9, 7.1. So we are 1 stroke after this bright line here, and we're going up all the way to 112. So keep your eyes, guys, on it. 112. We're in this line here, so 112. So we are 110 here, and that's going to be 112 right here. So that's going up by 2. And then finally now we're at 8 to 120. So we know that 8 is all the way out here. So this is, okay, let's look at 8. So that's 7.5, 7.7, 7.9. So this is this bright line here. That's 8, this bright line here. So all the way up to 120, all the way here. All right. So that definitely took some time. So we're going to go ahead then and draw our curve. All right, so we're gonna then zoom out a little bit here. So we're gonna go here, points. Let's continue like that. Okay, we're gonna continue like that. It's not really clean, guys, but you get what I mean. And that's our graph. All right, that's cleaner. All right, but on the computer it's a little bit more challenging, guys, to get the points plotted. So hope you guys followed there. All right, in terms of where we need to put our points, and you should have a much better drawing graph than mine. This graph should look something like that. Okay. And it says here that we should use your diagram, that's your graph here, to find an estimate for the median mass of newborns. So we know that the symbol or the notation for median is Q2. Q2 is equal to n plus 1 divided by 2. All right. So that's going to be 120. I say here 120 plus 1 divided by 2, that's 121 divided by 2, and that's 60.5. okay, that's the median weight. So if you go here and we find 60.5, okay, so that's 60. All right, so we're gonna do, because it's 120, so the median is at 60, come across like that, and at the point where it touches the curve, boom, right here. Let's zoom up and make sure that we're good. It touches the curve about here. I'm going to just kind of scroll down. It says an estimate, so this should be close enough to our result. Let's come down and see where it is at the moment here. So it's coming down, and it seems as if it has landed just one place before 5.5. So that's about 5.4. So the median mass, as it says here, it says use your diagram to find the estimate of the median mass for the newborns, so that this equal then to 5.4 kilograms. All right, that's the median mass. Beautiful. All right, and then that pretty much brings us to the end of that statistics question. It was a little bit tricky. I had to actually pause the video. That particular point there kind of threw off the graph a little bit, so that's something worth making note of. All right, so hopefully you guys got some help in that area then. So we're going to be looking at, say here, question 6. The diagram below shows a hemispherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12, which we can see here. That's 12. And the height is 17, which we can clearly see here. That's 17. And the radius of the bowl is R, which we can see labeled here. All right. And so we are to show that the volume of the cylindrical tin is 1,923 cubic centimeters, and we are to correct our answer to 4 significant figures, all right, which is obviously 1,923. So if we go back, you can actually use your formula sheet. If you forget the volume formula for a particular prism, it says here that V is equal to area times height. So if you go back to the front of the exam paper here, if I just kind of zoom up, just give me a second here, guys. So if you go all the way back up here, all the way to the front of our paper here, guys, you will find then that your formula here works out to be V is AH. Not sure why it's not coming up, guys, but let's see here. As you can see here, the volume formula of any prism is in fact V is equal to area times height. So once we have that, then always check your formula sheet so you can see if it is that there's any useful formulas here for you. So let's just kind of scroll back down all the way to where we were here. Just a sec. Let's get back down to that page. Okay, just a sec, guys. I think we were on the statistics page here. Alright, here we go. There it's coming up. Alright, we plotted our graph successfully then. So we see that V is equal then to area times height. Now, since we're looking for the volume of the cylindrical container, then we know right away then that the cross section then is in fact a circle. So that's pi r squared times h. So therefore then volume then works out to, normally they tell us to use pi as a specific value, and they did specify that we should use pi to be 22/7. So therefore then we can go ahead then and say this is going to be 22/7 times r squared. They said that the diameter was 12, so the radius has to be 6, so that's going to be 6 squared, and then we're going to times that by the height, which is 17. All right, so then we can go ahead then and we can say here 22/7. So 22 divided by 7, and we're going to multiply that then by 36, because 6 squared is 36, and then we're going to multiply that by 17. We end up, say here, confirmed with the answer 1923.4, but they said 4 significant figures, so our answer then is going to be exactly what they've asked us for here, 1923. So 22/7 times 36 times 17. All right, confirmed. Now it says here that the bowl is completely filled with soup. When all the soup is poured into the empty cylindrical tin, 90% of the volume of the tin is filled. Calculate the radius of the bowl. All right, so we know right away that the bowl here they stated that it is a hemispherical bowl. So this is basically like a half of a sphere. All right, this is a half of a sphere. Now bear in mind that they've given you some help here. They said that the volume of the sphere is with radius r is v is equal to 4/3 pi r cubed. So right away then I'll know that if I go ahead then and say here, let me just grab here. So I know that the volume of a sphere is equal to 4/3 pi r cube. It's a half of a sphere, so it's going to be a half multiplied by 4/3 pi r cube. And so a half of 4/3 will then eventually be equated to 2/3 pi r cube, and that's going to be equal to say here the volume. All right, now we need to go ahead then and find the volume of the actual bowl. We need to go ahead and find the actual volume of the bowl here. So that's going to be 2/3 multiplied by 22/7, and of course say here times r cube, and that's going to be equal to the volume. Now bear in mind that we already found the volume of the entire cylindrical tin, which we already know here is 1923. So we then need to find 90% of this. 90%, because of course when all the soup that is in the bowl is poured into the cylindrical tin, they said here that it is 90% filled. So we have to go ahead then and do a slight calculation here. That's 90/100 multiplied by 1923. And so if we go on our calculator then and say 90% divided by 1923, and then we divide then that by 100. Okay, so that's a little tricky here. So that's 90 divided by 100 multiplied by 1923. We get 1730.7. So that's 1730.7. Just a second here, guys. So now that we know that the volume, 90% of the complete volume of the tin is 1730.7, this then becomes the actual volume of the actual soup bowl here, because when all the soup from in the bowl was poured into the cylindrical tin, it was 90% filled. So therefore then we can go ahead and say 2/3 multiplied by 22/7 multiplied by r cube is equal to 1730.7. All right, so we can do some cancellation if possible. There's nothing to cancel here, so we end up with 2 times 22. That's going to be 44 over, say here, 3 times 7 is 21 r cubed, and that's going to be equal to 1730.7. So now we need to isolate r cube. We're going to then divide both sides by 44 divided by 21. So that's going to be, say here, that r cube then is equal to 1730.7 divided then by the, we're going to say divide by 44 over 21. But once you're dividing a fraction, then we already know the result here. We're going to just change the sign to multiplication. So we're going to have, say here, 1730.7 1730.7 multiplied by the reciprocal of this, so that's 21 over 44. All right, so we're going to go ahead and 1730.7 multiplied by 21 and then we're going to divide the result here by 44. We're going to end up with r cube being equal then to 826 point, see here, 01. So now to find the radius, then we're going to cube root the 826.01. It definitely seems as if this particular question was CXC's go-to question. This is a challenging one for a lot of students if you don't have the understanding of how to transpose a formula. Definitely, guys, check out my transposition formula. I don't think I have any in-depth transposition question like this one. This requires a bit of analytical thinking as well as skills in transposition, so we definitely want to do that there. So that's 826.1. So that's shift cube root. Let's see if I can find my cube root symbol here. I don't think my calculator has a cube root on it, so just a second, guys, let me just grab the answer here for you. So that eventually then worked out to be 9.38. Did they state that we should leave our answer to anything specific? They did not say, but in the instructions at the beginning of the paper in part 1, they said that we should always leave our answer to 3 significant figures, or better yet, say 1 decimal place. So I'm just going to work with, say here, 9.4. right? So that's 9.4 centimeter. All right, so this is a very interesting question. Very interesting question then. So hopefully you guys got the knowledge you needed from this one. Tricky question here, guys. Very, very tricky one. Let's wrap this paper up then, and let's wrap this video up particularly here. We have in the diagram below points L, M, and N are on the circumference of the semicircle with center O and radius 18, radius 18. We're to calculate the area of the shaded section of the diagram. So let's make an observation here that the area of the shaded portion is going to be simply that we need to find the area of the semicircle, and we're going to subtract, say, the area of that triangle that is inside there. Okay, we're gonna subtract the area of the triangle that is there. So area of triangle. All right, so we know that the area of a semicircle is going to be obviously pi r squared divided by 2, and then we're going to subtract then the area of the triangle. Let's put some measurement here. It did say that the radius of the semicircle is 18, so we know right away that from the center here to this point here is actually 18, and over here so it's also 18, so the diameter here is in fact 36. All right, and then of course we know that the radius again from the top here, M, because they are on the circumference, we know that in this direction, and that direction, also this here, so is 18. All right, so then we can use, say here, the area of a right triangle. But since there is 2 right triangles, or this is 2 isosceles right angle triangle, we can just simply say here that instead of half base times height, it's just going to be base times height. All right, because half base times height times, say here, 2, these 2 cancel, so it's just basically going to be base times height. All right, so that's how we get that. So this base times height here will help us to find the area of, say here, the triangle. All right, so then base here is going to be 36. All right, let's just do it with the half base times height just so you guys don't get lost. Okay, so it's going to be half base times height times 2. All right, so that's going to be pi is 22 over 7. Questions are still connected. And the radius here is, say, 18 squared. And then all of that then will be then divided by 2. So I can just simply say here multiplied by a half. Same thing as dividing by 2. And then now we're going to subtract here a half again times the base, which is again 18, times the height, which is again 18. And then we're of course going to times that by 2 because it's 2 of them. All right, so let's do some cancellation here. We can cancel these 2 here. So it's just going to be 18 times 18. All right, for that side. And then over here, we're going to end up then with a half multiplied by 22 over 7 times 324. And that's going to be you're going to take away, say here, again, 324. All right, so let's do some cancellation here. I could cancel the 2 here with the 22 and I'll get 11. So I'll end up with 11 times 324 divided by 7. So that's 11 multiplied by 324 all divided then by 7. I'll get 509.14. And we're going to subtract 324 from that. We're going to end up with 185.14. All right, and so that pretty much would have been the area of the shaded portion based on that observation. All right, so that is what I want you guys to do. You guys want to practice to think your way through the problem simply by using your formulas and your analytical skills then. All right, so hopefully you guys got a hang of that. All right, you didn't have to do it all in one. You could actually go ahead and find the area of the semicircle, write the answer on this side, then you go ahead and find the area of the triangle, then you do the subtraction. I kind of did it in one line here, so hopefully it was not too confusing. If it is, just kind of just reverse the video a little bit and you can just follow step by step. All right, so that brings us then to this section down here. We're going to be wrapping up the question. That was 4 marks, so it was worth it. It was definitely worth it, guys. Actually, we got a double whammy. The paper repeated it, the question repeated itself. It says total area of the shaded section, so we have that. So we just did the calculation here. All right, so that's my bad. Not sure why the paper repeated itself. All right, so that pretty much brings us to the end of this particular section of the paper. This is questions 4 to 6. The measurement question was definitely a tough one at that. One of the toughest questions I've seen in a while, and definitely CXC came out with this one so far. So definitely, if you're not very good at measurement and knowing your formulas, then this might be quite a bit of a challenge for you. But there were some helpful formulas at the front, so it's debatable whether or not the question was challenging or not. It depends on your skill level here on this paper. All right, so thank you guys so much for watching this particular upload. I will see you next time in another tutorial video. Do not forget to hit the like button, subscribe, turn on your post notification, then leave some positive questions and comments down below, and let's just continue practicing and preparing for our exams. All right, take care. Until then, bye bye.